at the moment. So, I'm quite active on social media. If you are too, please do follow. This is me, Dr. Maxwell, Parfitt. My background is computer science and robotics. I came across into construction 5 years ago to deploy virtual reality and actually make it usable on projects. Sort of projects I cut my teeth on are Crossrail, HS2. I've started integrating with Tideway, but we do everything from small house building all the way through to multi-million pound or billion pound projects. Give you a quick introduction to why I see VR being needed. Traditionally in construction, we design a building, we then go out and build it, and then we spend the next 2-3 years testing, fixing, testing, fixing, testing, fixing. It's ridiculous. We're the only industry that does this, and we should change our ways. So moving over into the world of the digital prototype dream allows us to design a building, analyze and test it at a design stage, and then go and build it once and then only have minor corrections. And the cost savings that we could have as a sector are insane. But what I'm talking about today is visualization, and visualization is all about driving better communications, and I just realized I haven't pressed the bloody clicker. Sorry, I do swear. I'll try and keep it partially clean. You're all wondering what I was talking about. There you go, it's up on the screen now. So, this was Fulcro's first job as a company. This was 14 years ago. We did this visualization for the client, but also for the on-site construction guys to really show how these modular mechanical, electrical, plumbing skids would go together. This gave us full bill of quantities. This gave us a full cutting sheet. We knew all the parts that were needed, how much it was going to cost, all ahead of the time that we actually went and installed it. And then when we went out onto site, it was installed first time correctly. This was done 14 years ago, before the dream of BIM. And there you can see the factory showing the modular skids going together and actually it being delivered out on site. And the ability to do this was fantastic, but it's not been really done since. We need engaged clients who want to try and push the boundaries for betterment for themselves. Another project that we've been engaged on, this was the Teenage Cancer Hospital here in London, 2-story building that we were fitting out. We modelled everything down to 10mm drop hangers so that when we went into the building, we knew that the trades were installing correctly first time. That originally was a 6 to 8 month job. We were completing 6 to 8 weeks rather than months. So massive time saving just by using visualization, making sure that our CAD models were fit for purpose. But anyway, what is visualization? The whole idea of visualization is being able to get your point across. Can you visually depict something and get it out in front of people? So we go right back to the Egyptians' hieroglyphics, but even further back to cave paintings. And so when we actually take this out into the world, 40,000 years ago, we were scribbling on walls. This was our way of showing the world our impression of it. About 500 years ago, Leonardo da Vinci drew the Vitruvian Man. We started looking at isometric drawings, dimension drawings, being able to have cutting lists so we could drive efficiencies. Jumping forward to a bit more modern, 58 years ago, we started seeing computer graphics coming along, so the first line-based drawings. If anyone recognizes the box 38 years ago, I know Martin, if he's in the room, has played on it. He's at the back. Yeah, this was an arcade game, very early VR. We also got things like haptics, which allow you to physically reach out and touch the virtual environment. And we'll start seeing these technologies coming along. But the thing that really moved me as a kid was Star Trek. The holodeck on Star Trek, being able to recreate anything in 3D at life size around you and being able to stand in it. And whilst we're not at the stage of actually being able to reach out and physically touch holograms, we can at least present ourselves with a 3D environment. And it's great seeing the technology from my childhood that I saw in sci-fi finally coming to being used and a usable tool. 6 years ago, we had the launch of the Oculus Rift, and this really spawned the second age of virtual reality. And lots of people bought into it very quickly and thought, yes, this is the future. And then lots of people very quickly realized, oh my fucking God, I can't get my data into it. What the hell? And it just plummeted down to the pit of despair. I have to say, we are now getting to the stage, and I've got a slide later on, we're coming up onto the plateau of productivity, people. VR is of age, we can use it because finally the software companies have realized to make it usable, it has to be linked to our live data. In construction, if something is more than 30 minutes old in our company, it's out of date. If I have to send a model out to an external graphics company to be processed for virtual reality, and that takes 3 weeks, my data is useless. That visualization is useless, and I've spent a shitload of money getting something that's basically a paperweight. Now, we can get from CAD to VR in a matter of seconds. So there's a couple of people out there. Make sure you go around and speak to them and try their demos, because it really is getting to a point now where productivity is key. And then 2 years ago, Microsoft launched the HoloLens. There are other mixed reality devices out there, just to do the disclaimer. But the technology is there, it's usable, and it's improving all the time. So, VR and AR in construction. 1980s, we were able to do the top left image, sort of neighborhood design. If you've ever bought a new house off plan, you'll have probably seen a shiny graphic with something like that on it. 1990s, we were able to stand you on the sidewalk virtually and show you what a development might look like. And then in the late 90s, early 2000s, the top right picture, we're actually starting to see the technology get to a stage where you can stand physically inside your environment. So that picture there is the University of Reading Cave, multi-million-pound installation. That technology, I'll show you what it's become now. And if you go out and see Vitalis, they've got their Powerwall out there. So this technology is being used. The bottom row is augmented reality. So being able to overlay CAD models into the real world just on your mobile phone. Everyone's got one of these in this pocket. So most people have 2 these days. This is the iPhone 6S. It's not modern by any stretch of the imagination. It's a 4-year-old handset. This thing has 800 times more processing power than the entirety of the Apollo moon landing mission that NASA owned at the time. That's how much computing power you've got in your pocket. We need it to be used out in the real world. So finally, software is beginning to catch up, and we're seeing things like photogrammetry, being able to go out and laser scan or take a scan with your phone and get that 3D model straight into your CAD. These are all incredible things that are coming on stream. A lot of you have probably seen head-mounted displays. Now, I know we've got a couple of different industry verticals in the room. Again, I work mainly in construction. To me, in construction, head-mounted displays, as cool as they are absolutely fecking useless. The reason being, they're single user. As soon as you've got it on, you're the only person that can see what's in there. Yes, you might have a computer monitor that shows you what people are seeing, but only you know truly what you're looking at. So you can't have collaborative conversations, and you always get Joe the fool in the room coming and tapping you on the shoulder. For me, head-mounted displays are a step backwards. However, room-scale virtual reality, where you can stand inside your models at life size and discuss and collaborate and work as a team, suddenly this technology is becoming really interesting, because that gets you into your information, that gets you into your environment. You can take your clients in and show them what's going to be designed, what's going to be built, and they can give you rich feedback rather than trying to give them that information on big sheets of A0 paper. So I'm going to show you a quick video about the FullMax Cube, which is our product that works in this area, and it really drives home the fact that you can get inside your VR data now.
Step into your project and visualize reality with this fully immersive and collaborative environment. Engineer, optimize and finalize better outcomes whilst interacting with your project BIM. Introducing the FullMax Cube, the flagship product of the FullMax innovative virtual and augmented reality solutions. This compact solution will fit into any office space and even site cabins, and comfortably allow teams of up to 6 people to simultaneously view and discuss the project in detail. Assembled in less than 3 hours and user training taking just 12 minutes, the FullMax Cube can be up and running for a design review in less than half a day. Access BIM data live while in the virtual environment, enabling teams to interact with graphical and non-graphical information to make better decisions, resulting in better design and operational outcomes. Powered by the FullMax Keystone software, your project teams can easily take their virtual design and construction data from authorship to virtual reality in minutes. Project security is maintained as model processing happens within your organisation by your project teams. To find out more, visit fullmax.co.uk.
So suddenly you can take your live project data put it into VR and put your clients into their building before you even put the first spade in the ground. How have we been using this? Well, Crossrail, we had one of our devices in there for 18 months. It was fantastic. The picture here shows some of their directors inside their new Whitechapel station development. But the real benefit that I saw was when we had the London Fire Brigade come in. And this was still whilst they were digging the holes in the ground. And the London Fire Brigade came in and went, right, let's walk around each of the 21 new stations. Okay, we need a better access route there. We need a better refuge area. Have you thought about this signage for emergency evacuation? And we were able to make those design changes at a design phase rather than having the London Fire Brigade come out to a brand new station and go, that's wrong, that's wrong, that's wrong, fix it before you're even allowed to open. So having that buy-in early in the design phase has saved millions on the project. But it also allows us to do things like public engagement. Everyone's heard of HS2. It's going to be going straight up the country. It's going to be going through so many different communities. Having this technology out there to show the community how it's going to affect their environment helps them engage rather than just reading the tabloid newspaper and all of the negativity around the project. They can actually have some feedback into, okay, could we change this design slightly? We've had school children in this environment. They have been walking around the Colosseum in Rome. We've had students standing on the surface of Mars whilst in their classroom, giving them that experience. This technology exists. It gives them so much more a richer way of learning. I'm going to skip through a couple of slides just because we're going to try and get back on schedule. There's some pictures of it in use. So AR in construction, this is using the power in your pocket. Everyone's got a mobile phone. Most mobile phones are capable of AR these days. The top left picture there, someone's holding an iPad, there's a marker on the floor, and it's overlaying new staircase designs into the space. So the client can then flick through different designs from a catalogue and choose what they want. The picture bottom left, what we have is a marker out on site at a groundbreaking ceremony. So anyone with a device can hold their phone up and see what the new building is going to look like in situ on that site before the first spade has even gone in the ground. But moving forward into the future, if we know where underground services are, rather than having to send out a survey team every time to dig up a road, if we can visualize where the services are and only attack that section, again, driving efficiencies, and technology allows us to do this. Now, in the construction sector, we have rooms full of these. Everyone recognizes a big piece of paper. We actually have specific fire insurance on our building because of the amount of flammable material in it. Because every project, legally, we have to deliver these to the client. Client picks up a piece of paper, and if you've ever done a home extension or home improvement and you've been given one of these by an architect, you probably looked at it and gone, okay, what's that actually mean? What we can do is take that, and the picture in the bottom is the video coming straight out the tablet, and overlay the 3D model directly onto that 2D. And that gives that buy-in. You understand that space around you. And again, technology is enabling this. So a couple of names you'll see around the event here. All of these guys allow direct CAD to VR in some form or another. There are plenty of other companies that do it. This is just a snapshot at the time I made these slides. But what this allows you to do is get from your CAD straight in and use it. Applications for this, far-ranging. There are applications I haven't even thought of yet that you would have from your own sectors that you could deploy VR and AR to. One of the critical ones we've been using it in construction is training. We don't want to send green rookies out onto a site, say a high-speed rail line or beside a big piling rig, because they are dangerous environments. However, if we can get them to do the training in a safe environment, they can screw up as many times as they want, get hit in the face by a backhoe as many times as they want virtually, because we're not going to kill them, but they can learn and understand why certain areas of an environment are dangerous. It also allows us to then do pre-assessments, so we can see when someone has completed the training ready to go out into that environment. There's a very quick learning curve. People learn by doing. If any of you have kids who are currently learning to drive, if they're with one of the big driving schools, chances are they're not even going to be getting in a car for the first couple of lessons. They'll be getting into a VR simulator so they can learn clutch control, they can learn maneuvering, they can learn and crash into as many virtual vehicles as they want rather than doing it in the real world. Time to proficiency, we're seeing it in things like crane operators. Tractors, students who are learning to drive agricultural tractors, learning in VR. Dentistry, welding, there are so many possible applications. If anyone has a tower crane on their site, I'm fully qualified to drive it. After 60 minutes in a simulator, I have no practical experience, but I'd love a go. But that driving simulator is great. I had an S-shaped curve. I had to get the barrel through it without knocking anything over. The last level of that game was purposefully knocking cars off a multi-story car park. It was great, but I am fully qualified to drive that crane. Again, back to Crossrail, taking scan data. So it's not just virtual environments, taking real-life scan data of an environment and getting back into it. So this here is Farringdon Station on Crossrail, circa November last year from scan data. You can get in there, you can understand the environment, you can see where things were installed before you put up, say, a ceiling panel. So you know exactly what equipment is there. This is as-built modeling. Being able to get in there, interrogate this information, and be able to maneuver through it. Very useful for, again, site analysis. Say you've got a fire brigade can get in VR en route to the site and find the best route through to that area. So some use cases. Left image is Papworth Hospital. This was great. Lead architect versus NHS nurse. It was beautiful. She came in, he was very proud of his design. That's shit, that's going to kill someone. Why the fuck's that there? Who the fuck designed that? She ripped his design to shreds. We were actually surprised he didn't throw himself in front of a train on the way home. Hats off to him, he didn't. 3 weeks later, he called us and said, I want to do that experience again. I've addressed 90% of her concerns, could have the same nurse. And it was a much better engagement. And he told us after those 2 one-hour events in VR and the 3 weeks between, he's probably saved himself 6 months of rework out on site, which could have cost the project millions. On the right-hand side, transformer electrical plant on Crossrail that was being investigated for access routes. On the left, having public engagement to make sure these tower blocks weren't causing an urban canyon. And on the right-hand side, Wimbledon Court 1. This is the new boiler room. Because we're putting a moving roof onto Wimbledon Court 1, we have to refit the entire building with an AC system. And we are doing the fit out and all of the installation program using VR because we can get the trades on site to actually come in and look at the install process. Moving forwards with augmented reality into the world that we live in, if we've scanned something before we've put up a skin, we can then get back to it and understand the environment that's there. So let's take, for example, that wall over there. Say I was refitting this building and I wanted to knock that wall through. Is it load bearing? Where are the pipes? Where are the studs? Can I physically go through that wall? If I've got the scan data before that wood cladding went on, I've got all that information. I can make that decision a lot quicker rather than having to have the delay and the cost of having a survey team come out to tell me something that I already have the information about. The technology is letting you get to it. And then this will allow you to get in. So Bam Nuttall here looking at doing retrofit of a building with SLS channeling. Now, I know we're short on time. It was a very quick, brief look through things. I've got a whole load of augmented reality cards on me, so come grab them off me if you see me, and then you can have a go. But thank you very much, and take some questions if we've got time.